Hello everyone, I hope you're doing well. Today I would like to talk about collapsible tooling. We, composite geeks, love to push the boundaries of designs and manufacturing using composite advantages. Complex shapes, no fasteners, material only where required, less assembly operations. All of this lead us to an amazing accomplishments like this one, this, also this one. But, because there is a but, we still face one big challenge. We need to unmold the part. Until you're able to hire a genie to make disappear the tool after the cure and reappear for the next part, what you need is a tool which becomes smaller than your cured part. We used to call them collapsible tooling. You can find this tool in composite or metalling, fully automatized or operational by hand, airtight or not. There are a few questions you need to ask yourself when you think about collapsible tooling. What is my budget? Is it for prototype or for program life? What is my production rate? What kind of lifting equipment is at my disposal? What is my part material? And what kind of print is allowed on my part? For the tool, these questions are translated by: what is the gap allowed between my different sections? How will I lock this section together? Can I have heavy section or do I need them movable by hand? How can I make my tool airtight? Is the difference of thermal expansion between my tool and my part is enough? Let's look at them one by one. To minimize the print on the part, you need a smaller gap possible between your sections. This is a scale which rates the different adjustments you can have with different classic manufacturing solutions for tooling. Composite section obtained directly from the models without extensive adjustment. This is the base for the tool life, but also the bigger gap you can have. Metallic section 5-axis finish. The gap will directly depend on your section profile, which itself depends from your machine precision, shape complexity, and of course the size of your sections. Composite section, one directly from the model, the second machine and adjust by hand. This is a better gap, but the tool life will decrease. Finally, metallic section, machine and then adjust by hand. This is definitely the best gap you can have with a better tool life. But be careful, it's expensive and also the edges can be very sharp. With the gap comes the question of the locking system to hold the different sections together. You have very classic and simple systems such as pins and clamps. There are also automated solutions such as pneumatic jacks, which are able to handle a classic 180 degrees composite cure. You have to be careful of three things. Hyperstatic, too many locking points and you don't lock at all. Accessibility, do my operators have access to these locking points? Finally, section weight. Do I need a pressure to lock them or can I manipulate them by hand? Speaking of manipulation, weights drive the show. It depends of course of your part size, but also of your tooling material or the number of movable sections you have. It also depends of your manufacturing strategy. For high rate production, you may want an autonomous station with a movement system directly within the tool. Different mechanical solutions are available, such as worm screw or racks. But remember, you usually need to keep the power system within the working station because it's not able to handle the Q cycle. But if you have a crane available or if your sections are not that heavy, you may not need a movement system within your tool. One of the most common issues you face when you've got a collapsible tool is an air leak between the different sections. The simple way, trap the complete tool in a big vacuum bag. Easy for small parts, not the same game for high rate production or very big parts. You can also use an airtight seal between the different sections. Different solutions are available. Classical seal, not a very durable solution and the efficiency can be variable, but it's not expensive. Inflating seal, a more efficient solution. But be careful, you may need to change it on a regular basis and don't apply too much pressure to not open the gap between the different sections. Another solution is the vacuum room. The idea is to create a vacuum room on the edge of your sections to isolate your part from the external environment. It's an easy solution to implement on metallic tooling, not always easy on composites. There is a last solution to have a smaller tool than your cured part, which make all we discussed completely obsolete. It is to use thermal expansion difference between your part and your tool. I have scale thermal expansion of classic material used for composite parts, but also for tools. Sometimes a steel tool for a carbon epoxy part or an aluminum tool for a fiberglass epoxy part might be enough. Of course, the price to pay may be your profile part accuracy, because, as you know, spring bite and thermal expansion on complex shape are not always easy to predict. At this point, I'm sure you realize I don't have a simple answer to your short question. The truth is, it depends. That's why I strongly recommend you to define the context you are on, with the question we saw at the beginning of the presentation. What is my production rate? Is it for a prototype? What kind of requirements are on my part? Etc. We can also help you to define the best recipe, so just ask. I hope you enjoyed the presentation. Please comment, give your personal opinion. You can send me a private message or share your comment with everyone. I will be happy to answer. Thank you for your attention, take care of you, and see you soon.